This is the tundra. There's more than 1,600 billion tons of carbon in the tundra. That's twice as much carbon as there is in all of the Earth's atmosphere. This carbon cycles back and forth from the tundra to the atmosphere. It moves from the atmosphere to the tundra when plants photosynthesize, taking in atmospheric carbon. It moves back the other way when plants respirate, taking carbon from the tundra and moving it to the atmosphere, and also when microbes in the soil decompose organic matter in the tundra, moving carbon back into the atmosphere. In the summer, photosynthesis dominates, moving much more carbon from the atmosphere into the tundra. So in the summer, we say that the tundra is a net carbon sink. When the sun goes down and the snow starts to fly, however, photosynthesis stops altogether, while decomposition by soil microbes continues, moving carbon from the tundra back into the atmosphere. So in the winter, we say that the tundra is a carbon source. On an annual basis, taking into account carbon moving from the atmosphere to the tundra in the summer, and from the tundra to the atmosphere in the winter, the tundra is overall a net carbon sink, with much more carbon flowing from the atmosphere to the tundra. That's why there's so much carbon in the tundra in the first place, having built up over all those years. In the past, the balance of these cycles has moved carbon from the atmosphere to the tundra, moderating the concentration of carbon in the Earth's atmosphere. But what is the effect of climate change on these cycles? These are important questions because, as we can see from this map showing climate change in the dark orange colors, the most intense warming effects on Earth are seen in the Arctic. Moreover, warming effects in the Arctic are greater in the winter than in the summer. To answer these questions, Polartrec researchers Elizabeth Webb and Elliot Friedman have been studying the effects of weather on the carbon cycle here in northern Alaska. Polartrec researcher Elliot Friedman has been using an electrical array like this in the permafrost near Barrow, Alaska, to study the activity of microbes in the soil that produce methane, a very potent greenhouse gas, and how its production is changing as the Earth's climate warms. Further south near Healy, Alaska, Polartrec researcher Elizabeth Webb from the University of Florida has been studying carbon dioxide flux from the tundra as it warms. In the tundra, there's an active layer above the permafrost, and in the active layer, the soil microbes are busy breaking down organic matter and producing greenhouse gases, carbon dioxide and methane. What researchers are finding is that as the tundra warms, the permafrost is starting to melt, increasing the active layer and increasing the activity of soil microbes, producing more greenhouse gases, more carbon dioxide, and more methane. What is the effect of a warming tundra? Well, in the summer, with warmer temperatures and a longer growing season, photosynthesis increases, moving more carbon from the atmosphere into the tundra. At the same time, plant respiration and decomposition by soil microbes also increases because of warmer temperatures, moving more carbon from the tundra back to the atmosphere. Overall, in the summer, the effect is that more carbon is moving from the atmosphere to the tundra, a phenomenon known as the greening of the tundra. And this is a good thing from a climate perspective. However, in the winter, photosynthesis still stops altogether while decomposition by soil microbes continues, thus moving carbon from the tundra into the atmosphere at an increased rate. What is the overall effect from a warming tundra on the Earth's climate? Well, we know that in the summer, with increased temperatures and increased photosynthesis, the tundra is becoming more of a carbon sink. While in the winter, because of increased temperatures and increased soil microbe activity, the tundra is becoming more of a carbon source. So where does the balance lie? Preliminary research shows that depending on the amount of winter warming and increased soil microbe activity we get, The tundra may change from being a carbon sink that takes up more carbon on an annual basis than it gives out to being neutral, where the amount of carbon entering and leaving the tundra every year are equal. At even higher levels of warming, it may be the case that the tundra goes from being a carbon sink to actually being a carbon source, releasing that 1,600 billion tons of carbon that's been building up over the years. This could have serious implications for the Earth's carbon balance and for climate change in the years to come. The answer to this question requires more research, and the Polartrec team will be out there trying to find the answers to these questions in the years to come.
But my brother